Greetings viewers, in this video we'll go through Cambridge A level or AS level further maths component 1 paper 1 further pure 1. This is the variant 1 from the May June 2025 series. In this video we'll try to do question 7. Given us this curve equation, it looks like a rational function and they want us to find the equation of the asymptote of C. Okay, remember the asymptote, we have the vertical and the horizontal asymptotes. So I think it's something we want to find the pole of the function, right? So when there is asymptote, it looks like there's a pole there. Let's do the vertical asymptote first. If you can recall, vertical asymptote is looks let's say this is the Cartesian axis. If there's a vertical asymptote, meaning that is have something like that lah. It does not touch. And how come this happened is because that it approached to infinity. Yeah, it approached, but it never really gets anywhere lah. So that's why at this point we say it's undefined, or it depends on how you want to look at it. But we usually call it as undefined. So it means it's divided by 0. So for the vertical asymptotes, we look at the denominator. We will see where does it equal 0. So let's factor the denominator a bit. On the denominator, you can see that there is a quadratic equation which we have factorized into its linear factors. And when each of these equals to 0, so we can get x equals to negative half and also x equals to 4. So at these 2 points, there will be 0 on the denominator, and therefore this type of situation will happen. So there will be 2 vertical asymptotes here. Okay, now what happened for the horizontal asymptote? Let's say what type of function that there is a horizontal asymptote, something like 1 over x. 1 over x, it looks like that, right? So there is a horizontal asymptote at this point, or y equals to 0. How come, or what kind of condition that this happen is for, we want to see when x tends to a very large value or in infinity, then we want to see where does y end up, right? So that's the concept of the horizontal asymptote. So let's try and do that on the y. Okay, so we try and take the limit as x goes to infinity. For this type of, if we plug in infinity everywhere, so it will be infinity over infinity. So we try and do some manipulation. We divide the top and the bottom by x squared. Now all the x is in the denominator of a number, right? So when x becomes bigger or gets to a very large value, all of this will become a very small value, so that is very insignificant, and we're left with just 2 over 2. Okay, so this is y, y when x goes to infinity, so 2 over 2, that's just 1. So this is the horizontal asymptote for this curve, right? So there is a 2 vertical asymptote and 1 horizontal asymptote. Okay, part B, find the coordinates of stationary points on C. Stationary points, if you can recall, what is the condition is that the derivative of the function, okay, the derivative of the function must be equal to 0 at the stationary point. So let's try and take the derivative of this. I think you're going to use the quotient rule, which is in the formula sheet, I think. Okay, so this will be your derived expression, and you try and find or isolate back the x. So that x coordinate will give you the stationary point of y lah. So you can sub in back into the original curve equation. We have found that there is 2 values of x which satisfy this derivative equals to 0, which means there are 2 stationary points that occur when x equals to 1 and x equals to negative 5. So we'll do, okay, we sub in x equals to 1 and also x equals to negative 5 back into the original equation. Then we get the y value, and that will be our 2 coordinates. So we have x equals to 1, then y equals to 1 over 3. So there is the first point. The second point will be x equals to negative 5, y equals to 25 over 27. So the two stationary points there. Okay, question C, now we want to sketch it. Okay, so these previous questions, they're kind of guiding you, giving you hint, okay, what the information that you need. So obviously you have your vertical and horizontal asymptote, and then you have your stationary point that occurred here, these 2 points. So, okay, what else we need is the intersects, right? So maybe we can sketch out an axis first. So please use your ruler for this step. So the intercept when y equals to vertical intercept x equals to 0, y will be equals to 0. Okay, so vertical intercept at 0, 0. Okay, horizontal intercept you have 2, right? Because you can when y equals to 0, so we only consider the numerator lah, because the denominator you can throw to the other side. So you can have x equals to 0 and also x equals to 5 over 2, right? Yeah, 5 over 2. So you have two um what we call horizontal intercept. So horizontal intercept, you'll be at 0. Okay, 0, 0, that was the one before, and then also 0, 2, sorry, 2050, or 5 over 2, 0. Okay, and then again you have your asymptote. Where was it? Negative half and 4. So maybe I just sketch it out first. There's a brief sketch and then 4. So it is x equals to 4, x equals to negative half, and then label yx. Okay, so obviously you can try and plot the point about, or you can test some values, right? Because we know the stationary value. Okay, maybe also, yeah, stationary point, you have 2, 1, 1 over 3, and minus 5, 25 over 7. So a stationary point, we can kind of guess from there what type of shape will it be. And then also there is a horizontal asymptote. Let's sketch that also. From the stationary point, 1 over 3. So it's probably somewhere here. This is 1. Hey, no, sorry. 1 is here, then 1 over 3 is maybe here. So from here, either you can from up to down, is a smiley face or a frowny face. You can plug in some value to check. But what I can tell you is, maybe you look at the value of the top and the bottom. So at the top, the two roots, there will be x equals to 0 and x equals to 5 over 2. So within these two constraints, x equals, I mean the y value will be negative. And outside of that is positive, right? So, and then the bottom one, you have the two roots also. Where was it? Yeah, 2x plus 1. Sorry, so the bottom one, the roots, you have x equals to negative half, and then x equals to 4. Okay, so that means what that means is that within, I mean from this vertical asymptote, this bottom one will be negative, but the top one, that will be positive. So there will be a negative value. Okay, positive divided by negative, there will be a negative value, and then you rise from the bottom of the asymptote through the this one, the origin. You go up and come back down. Of course, you label the this is the stationary point, and then again you label this origin. This is the intercept where we have discovered 5 over 2, right? 5 over 2, 2.5. So that's the middle part that we have done so far. Then we also look at beyond these two lah. Beyond these two, we already know it's positive. because yeah, that's the root. So outside these two values is positive. So we can draw it like something like that. So you come from the vertical asymptote, then don't touch the horizontal asymptote. And on this side, on the left side, okay, on the left side a bit tricky because we know um here will be, I mean outside here there will be positive value, but on this side it will coming from below, okay, below the asymptote. So it will go below and then it won't touch it. It's from the right hand side, it will go from the top and it won't touch it. But on the left hand side, it will go below and then very close to it. Okay, so it's something like we are approaching, or just now we do the limit, we are approaching the positive infinity. But so that gives us the right hand side of the graph. So this is the positive infinity side. But on the left hand side, you're going to the negative infinity. So that will give you, you're approaching from the negative side of the infinity. So they will still give you one, but you're going from the bottom. Okay, so that is the asymptote y equals to 1. So please use your ruler to label this in your exam. I mean, drawing all the asymptote, the Cartesian plane, please use your ruler. Okay, so I do not have ruler for this software. Is there anything else I need to do? Setting the coordinate intersection with the axis. Yep, done that. Asymptote, also done. Okay, so that will be this part of the sketch. Now we want to sketch the modulus of this. So basically it's the same thing. Okay, so I basically I just copy back whatever we have before, right? But now for modulus graph, all you need to do is just flip anything that's below the x-axis, just flip it up. Okay, so just now from the bottom asymptote, you from go to the top, cross at the origin, up back, and then down at 5/2, and go back up. So this again is 5/2, this is the origin, this is the stationary point 1/3, um and what's coordinate 1, right? 1. Okay, another thing here also, another tip, why is it going from the bottom is on the left hand side lah, what explaining about this one, why is it coming from the bottom. Also given you a hint that there's a stationary point and at -5, right? So here it changed from a negative gradient to a positive gradient. So that's again, you're knowing it's going from the bottom and then it changed to a positive gradient, then you approach it from the bottom of the asymptote. Okay, same with here. So here will be -5. Then yeah, you can label accordingly. What was it? 25/27. Okay, 25/27. Okay, so that is about the graph sketching. So it's all about knowing the behavior of the graph, the asymptotic behavior, the turning point behavior, everything like that. Okay, maybe I clean up. And find in the exact form the set of values for x for which this inequality or the modulus inequality is true. Okay, so we sketch this, so it given us some hint lah. 1/9, 1/9, maybe I use red color, so it's around somewhere here maybe. So what we are aiming to find is the critical values here, 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 and here. So we want less, right? Less, so meaning is in between. So x is in between these two values. X is in between these two values. Okay, so let's try and do the algebra to find out those values first. So remember modulus, meaning you have two cases. The first case is the positive one, and second case is the negative one. For the solving for this one is based on your arithmetic, your algebra. Just rearrange and solve the quadratic equation. Okay, so we'll solve this now. Okay, so now we have ending up to get four values of x, right? Plus minus, then plus minus. So it doesn't really matter. So you can just put x is in between these two. Okay, so bigger than the minus square root, and then smaller than the positive square root. The same thing with the other case. So x is bigger than the negative square root, larger than or smaller than the positive square root, because I mean each of these pair giving us one of these points here. Okay, so this will be the two values of x for which this inequality, the modulus inequality, is true. And since it is, remember it asks us to give in exact form, so we leave it as a square root, or you want to simplify the square root also can. Just do not give as decimal point. Okay, so that will be, yeah, that's the end of this paper. Thanks for watching the video.